derivatives. We first give the definition for partial derivative of a function of two variables. Let z equal to f of x, y be a function of two variables, then the partial derivatives is defined in terms of the limit. The partial derivative of f with respect to x is the limit as delta x goes to 0 of f of x plus delta x comma y minus f of x y divided by delta x. Basically, this says to us that you want to find the limit or the derivative of the function f with respect to x. Treat y as a constant or coefficient. And then very similarly, for the partial derivative of f with respect to y, here we treat x as a constant, and then the y variables vary. So use the limit definition, what we just got through saying here, to find the partial derivative of f with respect to x and also with respect to y. So first, we found the partial of f with respect to x, evaluated at the point x comma y. It's set to be the limit as delta x goes to 0 of f of x plus delta x comma y minus f of x y all over delta x. So this is the limit as delta x goes to 0. Wherever we see x, we write x plus delta x. This is plus 2y, now minus the function, and the function here is 3x plus 2y. This is all over delta x. We simplify, and so we have the limit as delta x goes to 0 of 3x plus 3 delta x plus 2y minus 3x minus 2y. This is all over delta x. Now the 3x's cancel out and the 2y's cancel out. Typically in the cancellation, when we're looking for the limit, everything without a delta y or delta x in it should go away. So we have left the limit as delta x goes to 0 of 3 delta x divided by delta x, and the delta x is canceled. We have the limit of a constant 3, which is a constant. Now, afterwards, we'll do the shorthand version for the partial derivative, and the partial derivative of f with respect to x simply means take the derivative with respect to x, treat y as either a constant or coefficient, whatever it is. And so here, if y is treated as a constant, think about this as just being the number 10. Take the derivative of a constant, you get 0 with respect to y. And we're looking for the partial of f with respect to x, we just get 3. The partial of f with respect to y would just be 2. Well, let's see. The partial of f with respect to y, evaluated at the point x comma y, is the limit. Here is delta y goes to 0 of f of x. X is fixed number. And this is y plus delta y minus f of x y divided by delta y. This is the limit as delta y goes to 0. The function is 3x plus 2y, but this y becomes y plus delta y minus the expression 3x plus 2y, and that's all over delta y. So this gives us the limit as delta y goes to 0. This is 3x plus 2y plus 2 delta y minus 3x minus 2y. That's all over delta y. Now what cancels here is the 3x and the 2y. So we have left the limit as delta y goes to 0 of 2 delta y all over delta y. The delta y's cancel. You have the limit of a constant, which is 2, and the limit of a constant is a constant.